Hi, welcome to the video solution for past paper. This is Edexcel IAL Physics, Unit 1, January 2020. Second video of the series, so let's start. Question number 16. Popcorn kernels contain water. When heated, the water turns to steam. The kernel pops and moves upward. Okay, so this is a diagram where we have unpopped popcorn kernel, and this is the popped one. And when it is popping, so it is going up, jumping. So the photograph above show a popcorn kernel just before popping and at the maximum height after popping. The time between the two photographs was 83 millisecond. Determine the maximum height after popping. So you have two choices in this question because they don't mention anything about taking measurement from the photograph. So they did not mention taking measurement from the photographs. They did not mention this. So you have two choices. You can use either the photograph. You can take measurement from the photograph. You can measure the distance between these two pictures using your ruler, and according to this height you can convert the scale. You can use the scale factor and you convert your measure height to find the actual height gained by the popcorn. So taking measurement from the picture. So one method is from the picture. The second method is you just imagine some particle, some object falling from that height from rest, because the kernel is at that moment is at rest position, maximum height. So you can imagine a particle at that height falling freely. So you can use S is equal to ut plus half at square, and you can take 0. Imagine that the particle is falling from some height, so you can do the calculation. S is equal to u is 0 plus half a is acceleration due to gravity 9.81 times t square, and t is 83 millisecond. So you can say that 83 into 10 to the power minus 3 whole squared. And then when you solve this, so your distance would be equal to 0.0337 meter. You can round it off till 0.034 meter. This is the height gained by the popcorn kernel after popping. Part 2. Calculate the initial speed of the popped popcorn kernel. So clearly you know that you have height and you have final speed 0, and you need to find initial speed. So you can imagine that at the bottom you have initial speed u that you need to find, and it is going up, and at maximum height it was at rest, so final velocity is 0, and you have already found the height, which was 0.034 meter in the previous part. So you can use equations of motion, and the best choice is you can use S is equal to u plus v divided by 2 into t. Now you have everything to figure out value of u. You just substitute the number. So 0.034 is equal to u plus 0 divided by 2 into time is 83 milliseconds. So 83 into 10 to the power minus 3. So you can make u as a subject, just rearrange this equation and you figure out value of u. So once you find the value of u, so u would be equal to 9 point, no, it's not 9 point, yeah, it is 0.82 meter second inverse. This is the speed, initial speed of the popcorn. The average water content in a popcorn kernel is 14% of the total mass of the kernel. A kernel is heated until it pops, steam is ejected downward, and the popped kernel moves upward with an initial speed of 1.5 meter per second. Calculate the speed at which the steam is ejected, and total mass of the unpopped kernel is 0.11 gram. So this question is all about law of conservation of momentum. It's more specifically, it is all about explosion. If you see the situation, explosion, and the explosion is a specific case of momentum. Now what is happening in this question? You have a unpopped kernel, like you have a maybe some thing at which you put a popcorn, and this is a popcorn kernel here. This is a popcorn kernel. Now when it is heated, so what happened? The water content inside, due to high temperature, the water content or steam goes down with some velocity v, and then this popcorn kernel moves upward with velocity, let's say 1.5. It is given here, 1.5 meter second inverse. So it is explosion. So before popping up, they were together, so as one mass, and now after explosion, two bodies or two particles or two objects are moving in a opposite direction. So that's what we can use explosion concept. And for momentum we need masses. They are saying the mass of the water is 14%. So you say that mass of the water mw is 14% of 0.14 times of 0.11, which is equal to 0.0154 gram. This is mass of the water that turns into steam. So after popping up, so mass of the popcorn kernel will be reduced. So mass of the popcorn kernel will be of course 0.11 minus 0.0154, which will be 0.0946 gram. Don't need to convert into kilogram, because we are using law of conservation of momentum. So you know that momentum before explosion is always in this case, because both the particle steam or water content before popping, they are at rest. So momentum before collision is 0, equal to momentum after the sum of the momentum after collision. So I am considering upward direction as positive. That means something is moving down. It will be taken as negative direction. So you can say that momentum after popping, momentum of the kernel, popcorn kernel going up, and you can figure out momentum of the popcorn kernel is mass into velocity, which is 0.0946 times 0 no, it's 1.5, its velocity, and momentum of the steam minus, why minus? Because it is moving in opposite direction. So minus momentum of the steam, which is mass of the steam, which is 0.0154 times its velocity. And now clearly you can rearrange this equation to figure out value of v. So V would be equal to 0.0946 times 1.5 divided by 0.0154, and then V would be equal to 9.2 meter second inverse. This is the velocity of the steam. Question number 17. An elastic cord was fixed between the end of an air track and a glider. The glider was pulled to the right given the elastic cord and extension delta x as shown. So this is the elastic cord, extension, this is original length, one end fixed, glider, okay, light gate is there. The glider was released and it moved to the left. A light gate was used to measure the maximum velocity of the glider. This was repeated for different values of delta x. Okay, keep changing delta x and then we can keep finding the velocity. So a student obtained the following result. Following result mean this is the graph that the student obtained. Okay, the principle of conservation of energy predicted that the graph should be a straight line through the origin. For the range of values of delta x used, the elastic cord obeyed Hooke's law. Explain this prediction. Okay, so we will have to apply law of conservation of energy. What is happening here? When you extend the cord, that means at that moment in the cord we have elastic potential energy stored in the glider, and when you are releasing, it is keep moving and keep moving towards the light gate. When it is passing from the light gate, you have some maximum speed. So you say that the elastic potential energy is converting into kinetic energy. So gain in kinetic energy, gained in kinetic energy is equal to the stored potential energy, stored elastic potential energy. I just wrote it for your understanding. You don't need to write. If you okay with that, you can directly write the equation. So you can say that half mv squared is equal to elastic potential energy, which is half k delta x squared. So half is gone, and then you can rearrange this equation for v. So v squared would be equal to k by m delta x square, and then if you take the square root, so v would be equal to square root of k by m into delta x. Clearly k by m root is a constant term, because k is constant, is spring constant or Hooke's constant, and m is mass of the object. So both the factors are constant in the square root. So this whole factor is constant. So now you can say that velocity is directly proportional to the extension. That's why we must have a straight line. Determine the stiffness K of the elastic cord. Mass of the glider is 300 gram. So we need to find a stiffness, and we need a force extension graph or some graph. Now you see here. So for this is the graph, and You see, how do you find the stiffness? Using the graph. Now, situation is, you know, V is equal to K by M root delta X. That's what we prove here. And now if you C, if you need to find the C here, K here, so you need to make K as a subject. So K would be equal to V square is equal to K by M, root is gone, and delta X square. So K is V square by delta X squared into M. So if you multiply M, which is given 0.3 kilogram, with the V square over delta X square, and where did we get this? This is a square of the gradient of this graph. You see, we have a V velocity here, and we have extension delta X. So if you find the gradient, of this graph, then gradient would be equal to V by X, or V by delta X, and you can make it square. So square of the gradient multiplied by mass will give you value of K. So you need to choose 2 points to find the gradient on this graph. So for best point is yeah, let's see, 0.5, and this point I'm just taking this point as 1. So this is 0.5 comma 4.4, and another point you can choose is 0.22, and okay, this one is fine. This is close point. So the coordinate of this point will be 0.22 comma 2, and now the gradient would be equal to y2 minus y1, 4.4 minus 2 divided by x2 minus x1, 0.5 minus 0.22. So the gradient would be equal to 8.6, and the unit will be equal to meter gone second inverse. This is the unit of the gradient. And now finally K will be equal to V square over delta X square. That means 8.6 whole squared into M. M is 0.3 in kilogram. So K is 22.2 Newton meter inverse. That's how you can find the value of K. Okay, so part B is when the glider was moved to the right by more than 0.5 meter, the graph began to curve. Explain why the shape of the graph changed. It's quite a straightforward reason, because we know that till 0.5 meter the graph is a straight line. That means chord is obeying Hooke's law. That's why we have a straight line. So meaning 0.5 meter is the limit of proportionality. If you cross this limit, then of course it will not be obeying the chord will not obey the Hooke's law. That's why graph starts curving. Question number 18. A student carried out an experiment to determine the Young modulus of copper. She added a mass m to the free end of the sample of a copper in the form of a long, thin wire, and the corresponding extension delta x was measured. This was repeated for increasing mass. This state the meaning of the term Young modulus. Young modulus, you need to just write the definition. Young modulus is the ratio between stress to the strain. So that's how we define the Young modulus, the ratio between stress to the strain. Part B, the student repeated the measurement of the diameter of the wire at a different position and orientation of the wire, she obtained the following results. So diameter is 0.23, 0.235, 0.30, 0.24. Determine the cross-sectional area of the sample of a wire. So you know that it's all about area of cross-sectional of the wire. So area of cross-sectional is A is equal to pi r square. But as they are giving diameter, so I will be using pi d square by 4, because you know that r is half of the diameter. Because of the square, we have 4 here. And now we need to find the diameter. We have a multiple reading of diameter. So first we need to find the average. So you just add these numbers. We don't have any anomalous result. So you do add and then divided by 4. So your diameter will be 0.23375, and then you can round it off till a 3 decimal place. So you can say that the diameter is 0.234 millimeter. And now just you can find the area. So area is pi 3.14 and d square, and d is 0.234 into 10 to the power minus 3 because of milli squared divided by 4, and then area will be 4.30 10 to the power minus 8 meter squared. This is the area. The student plotted a graph of m against delta x. She measured the gradient and obtained a value of 195 kg per meter. Determine Young modulus of the copper. Length of sample of copper wire used is 3.5 meter. So we need to find Young modulus, and as per definition, Young modulus Y is stress over strain. Stress over strain. That means you can say stress is force per unit area. Strain is change in length, which is delta x divided by original length. Let's call it x. Original length. I'm calling this as x, original length. So you can simplify. So y would be equal to f x divided by a delta x. And in this case, because the force is the weight of the hanging mass, so you can say that y Young modulus would be equal to m g x divided by a delta x. And now if you see the equation, if you see this equation, this m by delta x, this m divided by delta x, this is basically gradient that student measured. As per question, the student plotted a graph of mass against delta x. That means on the y-axis the student took mass, and on x-axis delta x, and from the line you have a gradient, the gradient. So this is m upon delta x, which is gradient. So you can say that y is in fact g x divided by a into gradient. It's just, I'm just writing for your understanding. You can skip the step whatever you want. So y would be equal to so yes, g is 9.81 times x. X is original length, which is 3.5, and divided by area. We found area in the previous part, which is 4.3 10 to the power minus 8 into gradient, and gradient is given as 195. So y, or the Young modulus, is 1.557 into 10 to the power 11 Pascal, or you round it off, you say 1.6 into 10 to the power 11 Pascal. This is the Young modulus. See, I did every step in detail. You can skip whatever you want. So the experiment was repeated by another student using a 2-meter length of a copper wire. Suggest how the value of obtained for the gradient and hence the Young modulus will differ between the student. Remember, first important point, Young modulus only depends on material. It does not depend on sample. So meaning material, what material from which the sample is made of. So Young modulus is all about a constant for the material. If you're not changing material, it doesn't matter how long the sample you choose. So only effect of the original length is about the extension, because how much extension there will be depends on how long initially you take the sample. So delta x is proportional to the length. So you know that the if delta x is increased, because you know here what happened here, because gradient is m upon delta x. So if delta x is increased, if extension is increased, then gradient will decrease, or vice versa. If you say if extension is decreased, then gradient will increase as per this relation, but Young modulus stays the same. Question number 19. A student used the apparatus shown to investigate the force acting on a uniform solid sphere placed in water. So we have a liquid water inside sphere, thread and balance. Okay, draw free body diagram or free body force diagram for the sphere when it is suspended in the water as shown. So you know that we have a situation in which some solid is hanging with the thread. So with the help of a thread, if something is hanging, we have tension acting in the thread. So one force is a tension along the string, the second is the weight acting downward, and of course the object is in the liquid or in the fluid, we have upthrust acting, and upthrust always acts in upward direction. So we have three forces acting. One is tension acting upward, T, upthrust acting upward always, and the weight acting down. So these are the three forces we need to draw on the sphere. Remember, all these three forces are contact forces. So when you draw the arrow, make sure that all arrows should touch the sphere. Okay. As the sphere was lowered into the water, the reading on the balance increased from 315 gram to 465 gram. Okay, so it is in the air when it is lower. So reading on the mass balance is increased. Fine. Explain the increase in the reading on the balance. Your answer should include reference to Newton's third law. This is a typical question, comes an exam using Newton, explanation of using Newton's third law, and the idea is, general statement is, if object A, due to some reason, object A apply force on B, applies or exert force on B, force on object B, then according to Newton's third law, object B apply force on object A in opposite direction, and in this case we have a resultant force in the direction of A or maybe in the direction of B. It depends on the situation, and due to that resultant force, then we have a phenomenon whatever we need to explain. So here what is happening, if you go back, when the sphere is lowered into the liquid or into the water, we know that water exerts force on the sphere in upward direction in the form of upthrust. Then according to Newton's third law, the sphere should push the water downward or exerts force on the water downward, and this downward force exerts on the mass balance, causing increase in the reading. So that's how you can write the answer. Next part, determine the mass of the sphere. Okay, so what is happening here? You know that because the sphere is in balance condition, so you know that upthrust plus T, which are acting upward, is equal to W, and W is mg, so you can say this is mg. This m is the mass of the sphere for a sphere. But problem is we cannot use this approach because there is no clue about T. So just forget this for the meantime. We are not going to follow this. But you know that as per definition, upthrust is equal to rho Vg. This is the definition of upthrust. And what is upthrust? Upthrust, as per definition, upthrust is weight of the fluid displaced when some object is immersed. That means this U can be replaced weight of the fluid, and fluid is water, so you can say that U is mass of the water, acceleration due to gravity. This is weight of the liquid displaced, so U is equal to mwg is equal to rho. Rho is the density of the liquid, so rho W, and V is the volume of the liquid, or in this case volume of the object, so I am just writing VO, and G is acceleration due to gravity. First you just cancel G just to get rid of this. Finally, so we have the situation, but we need to find mass of the sphere. And how can we find the mass? We can use definition of density, because density is mass over volume. So if you need to find the mass, then mass should be equal to density times V. And if we need to find mass of the sphere, so mass of the sphere S should be equal to density of the sphere into volume of the sphere. In this case, volume of the sphere, I said V naught. So I can replace this V naught with ms divided by ds. So you can think mass of the water is equal to density of the water, uh, volume of the object. So mass of the sphere divided by density of the sphere. That's it. That means you can figure out mass of the sphere. So mass of the sphere is mass of the water, density of the sphere divided by density of the water. What about the mass of the water? And mass of the water, if you go back to the previous slide, so there's a change in the mass on the mass balance. So if you subtract those number, you will get 150 gram. This is the mass of the water displaced, or 0.15 kilogram. You can use all these numbers to figure out mass of this sphere. So final calculation, mass of the water is 0.15 times density of the sphere. Density of the sphere is 2000. So this is 2000 divided by density of the water, which is 1000. So these three zeros are gone. 2 times 0.15. So this is mass is equal to 0.30 kilogram. This is mass of the sphere. Again, if you wish, you can skip a step like this. Don't need to waste time here. Okay, let's move on. The water was replaced with the same mass of oil, and the experiment repeated. The density of the oil is less than the density of the water. Explain what happens to the final reading on the balance. So you need to understand what is happening if you are replacing with oil with, of course, oil has a less density. So upthrust depends on rho Vg. So this V is the volume of the sphere. Sphere is same. Only thing is density is changing, and it is not changing, it is decreasing. So if density is decreased, that means upthrust will also decrease. So if upthrust is going to decrease, then the downward force will also decrease according to Newton's third law. Fine. So you can say that the reading should be decreased. So there will be less increase. Okay. Thank you very much for this video. I hope you understand. Have a nice time.